At this station, we're going to talk about macroinvertebrates. So first, I'd like to break down the word macroinvertebrate into two different parts. An invertebrate is an animal that does not have a backbone. If you put your head forward and you feel the back of your neck, you might be able to feel those bones. Those bones are your backbone or your vertebrae. So an invertebrate is an animal that does not have a backbone. The word macro can be seen as the opposite of micro. So if you think about an animal that is microscopic, you might need to use a certain tool to see that animal called a microscope. Well, macro is the opposite of that, which means it's an animal that is big enough to see with your eye. So today we're going to be looking for macroinvertebrates. So we're going to start by asking why macroinvertebrates are important for salmon in the first place. And as you may have learned from some of our pre-visit videos, macroinvertebrates are an important source of food for a certain stage of salmon in their fry stage. When they're really small, they're emerging from the gravel and they're starting to find their own food, and they're looking for macroinvertebrates. Additionally, macroinvertebrates can tell us how clean the water is, and they can do that by indicating the level of pollution that is in the water. So what we're going to do today at this station is sample some macroinvertebrates, identify which groups they fit into on a pollution tolerance level, and determine overall what the story that the macroinvertebrates tell us on the health of the Nooksack River for the salmon species that are living in this river. In order to collect the macroinvertebrates that we're going to identify later, we need to get them from the Nooksack River, and we want to do that safely and carefully. So we're going to use some equipment that we have here. This is called a D-net. You might be able to recognize the letter that you see here on this net, and it's really fine meshed, so a lot of the macroinvertebrates cannot fall through once we're sampling. We also want to be careful of our stream bank here and the gravel that's on the bottom so we don't disrupt a lot of it. As you learned earlier, salmon dig these nests called redds, and they're very sensitive and fragile when those eggs are in them. So we want to be careful of the gravel here so we're not disturbing a lot of it in the process of harvesting macroinvertebrates and collecting those for our sample. So what we're going to do is something called the salmon dance. And you'll notice that my net is downstream of me. I'm going to kick my feet around a little bit, stir up some of the gravel and some of those macroinvertebrates that are hiding under the rocks or hiding in the gravel, and they'll be swept by the current right into our net, and then we'll check out our sample later on. Now that we've collected these macroinvertebrates from the Nooksack River, we can start to identify them and loop them into pollution tolerance groups. These macroinvertebrates fit into 3 different pollution tolerance groups. Those that can handle no pollution in our water fit into group 1. Animals that can handle a little bit of pollution fit into group 2. And those macroinvertebrates that can handle more pollution and are the most hardy of our macroinvertebrates fit into category 3. So what we're going to do for the next part of this station is identify the macroinvertebrates that we collected from the Nooksack River and figure out which pollution tolerance group they fit in so that we can make a conclusion on the health of the Nooksack River based on our sample collected.
Bingo.
All right, let's dive in and see what we were able to find. Ooh, here we go. All right, here's our first macroinvertebrate that we were able to collect. You might see it looks like a worm. That's a really good observation. And one of the ways that we can identify the macros that we found from the Nooksack River is using this tool. And this tool is called a dichotomous key. And through a process of elimination, we're able to figure out, using our observations and the features we see, what species we just found. So let's work our way through. The first question is, does this animal have a shell or does it have no shell? And if you take a look at this animal, what do you think? I think it doesn't have a shell. So we're going to move over to this side of the category. And our next question is whether the animal has legs or no legs. Let's take a look. I don't see any legs there. All right, we're moving on. We're narrowing this down. The next question is whether this has tentacles or tails on the end of it, whether the animal is worm-like, or whether the animal is microscopic. And if you remember back to our introduction, we talked about all of these animals being macroinvertebrates, which means that they're large enough to see with our eye. So that tells me that we can narrow down and cut out that microscopic category. So what do you think? Does this animal look worm-like, or do you see tentacles or tails on the body? If I'm looking at this, I'm going to go with this animal looks like a worm. And our final step here is to figure out which worm-like animal we're looking at here. It looks to be pretty skinny, so we can cross off some of these ones that are a little bit wider. This one looks like it's bristly, and I don't see any bristles. So it looks like we're narrowing it down to these two here. We're looking at either a tubifex worm or we're looking at a threadworm. And this tubifex worm is reddish brown in color versus the threadworm, which has small hair-like features and swims in an S shape. And if we take a look at this, it doesn't seem to be swimming in too much of an S shape. I don't see a lot of hairs on it, and it definitely has a reddish brown color. So by using this dichotomous key, we were able to identify our first macroinvertebrate as a tubifex worm. All right, let's see what else we caught. These animals don't like to be caught, that's for sure. Here we go, got it. Let's put a little more water in there, make sure it's happy and healthy. Here we have a different version of a dichotomous key. This one helps us to identify our macroinvertebrates based on their size or features such as spots, number of legs, antenna, etc. And by using this dichotomous key, we're able to group these animals into categories. The macroinvertebrate I just found, to me, looks not like a worm. It doesn't look crab-like. It looks more like a beetle. So we can narrow it down to this category over here. And now I'm taking a look at the shape, the color, the number of legs. I don't see really long legs sticking out like in these two. And if I look really closely and count, I count 6 legs. So if you look at our last two here, which one has 6 legs? You may have found it. It's the crawling water beetle. So our next animal that we found is a crawling water beetle. All right, let's see what else we have in our sample. Oh, here's one. That was easy. We're lucky. They don't all act like that. All right, here we have a fly baby, which can also be classified as a nymph or a larva, other words for a young fly that's living in the Nooksack River. And let's check out this animal. It's moving pretty quickly. Once it stops, you might be able to see the number of tails that it has on the back of its body. If you can count those, I count 1, 2, 3 tails. So let's check it out here. Which category has 3 tails? I'm looking at either a damselfly nymph or a mayfly nymph. And if you look closely, you might be able to see on the side of the body here a little fluttering. What you're looking at there are the gills on the side of this animal. So that helps me to determine which one of these animals we're looking at. One of these has more gills than the other on the side. Can you figure out which one it is? You may have guessed it. We're looking at the mayfly nymph here. All right. Okay, let's see what else we have in our sample. This one's skirting along the side here. Got it. All right, so this one's very similar to the last animal that we found, the mayfly nymph. But this one only has 2 tails on the back of its body. You might be able to see those back here. So again, let's look at which of these animals on our key has only 2 tails. And by process of elimination, you may have found that it's the stonefly nymph as our next critter. All right, one more. I'm gonna save my personal favorite for last. And I wanna put a lot of water in here. Again, this one falls into our flies category, and this one is pretty unique. You might not be able to see many legs here. You might not be able to see many tails, but what you might see is that whole structure is moving. And what we've caught here is an animal that builds a case around itself. And you can tell on our dichotomous key here that we're looking at a caddisfly larva. Caddisflies are incredible animals. They build these cases, and if you look closely, you might be able to see some of the materials that are part of that case. We have some sticks. It looks like there might be some needles from cedar trees or other coniferous trees, and they mold that together to form a case, to form their home. And that's how they are able to stay hidden and protected from predators like salmon fry that might be looking for them. So that's our last critter, is a caddisfly nymph. Okay, now that we've been able to identify the macroinvertebrates that we collected from the Nooksack River, we can start to put them into their pollution tolerance groups and identify if we have animals in group 1, which are sensitive to pollution, group 2, which can tolerate some amounts of pollution, or group 3, which are pollution tolerant species. Let's take a look at our samples here. The first one we caught was a tubifex worm, and a tubifex worm is in group 3. The next animal that we caught was a crawling water beetle, and a crawling water beetle is in group 2. That was followed by a mayfly nymph, and mayflies are in group 1. The next one we caught was a stonefly larva or nymph, and that was in group 1 as well. And finally, we caught the caddisfly, which is also in group 1. So as you look at the species that we were able to sample from the Nooksack River today and see the categories that they fit in, you might notice that more of our animals are in category 1 than any other category. So take some time to think about, what do you think that means about the health of the Nooksack River for the salmon species that are living there? Do you think that based on our macroinvertebrates, it's excellent, fair, or poor?